Question 6 reads, in a single Venn diagram, illustrate the relationship between the sets of natural numbers. In a single Venn diagram. Illustrate the relationship between the sets of natural numbers which is n, integers which is z, rational which is this guy, and then irrational which is p, and real numbers. Real numbers which is r. So we illustrate on a set of in a single Venn diagram. So we have this guy. Suppose we have some universal, and then we'll have real numbers. We can even say, in such cases, we can say, okay, let our universal be a real. Because if you're talking about this, all these sets, natural numbers, integers, rational, irrational, and real numbers, then the universal becomes real numbers because all these others are subsets of real numbers. Then in real numbers, we now have a set of rational numbers. Then we'll have a set of irrational numbers. Irrational numbers and rational numbers are disjoint. So then we have integers in rational numbers. We have integers here. And then in integers, we have natural numbers. You remember we did a bigger Venn diagram of this nature where we had included complex numbers. We also had whole numbers. The difference between whole numbers and natural numbers is that natural number starts from 1, whole number starts from 0. So this is how you present on a Venn diagram. It's a very good question that somebody can ask you an assessment. Then question 7. Question 7. Hello.
How about the whole numbers? They fall under which one, rational or irrational?
They are rational. And they are integers.
All right, thank you.
Okay. Question 7, you are given the set A, -4, 1/4, and -√2, 0, actually 0.3 actually, 0.3, 1/√3, 0.3 bar, √2, then 3. List the elements of the following subsets of A. 1, a set of natural numbers. Natural numbers. We are listing now. Which ones are natural numbers? -4 and 3. We only have 2 here, which are natural numbers. I've put -4. -4 is not a natural number, it's just an integer. So natural numbers actually here is just the 3. We said natural numbers are count numbers from 1 and their whole numbers. Then 2, integers. Integers, we now start from -4, negative, positive, including 0. So we have -4 and 3. Then 3, come in. Then 3, we'll go to next thing. Okay, so we go to 3, rational numbers. Rational numbers, we have numbers -4, 1/4, 0.3, 0.3 bar, +3. All these numbers are rational numbers because you can express them in the form A/B, where B is non-zero. Then 4, irrational numbers. Irrational numbers. So we have -√2. We have 1/√3. We have +√2. This is irrational. We have any other real numbers. The whole set A. Okay. Let's now go to question 8. So here we're just listing these numbers that we already know. So let's go to question 8. Question 8. Express the following as a fraction. In lowest terms. A. Remember we did some examples here. So now we have from the theory sheet. A 0.48. B 3.375. C 12.13 under the bar. D -3.532. E 0.23 bar. Okay, let's see how far we'll go. Solutions. The first one, you let x to be 0.48. And then you count how many decimals do I have? So we have 2. So we multiply the whole equation by 100. So x times 100, we get 100x. 0.48 times 100, we get 48. Then we solve for x. So we divide by 100. We divide by 100. So we have x is equal to 48 over 100. Then we can simplify. So if we simplify, 4 can go in there 12 times and 25 down. So 0.48 is the same as 12 over 25.
So I've got a question.
Okay.
Why aren't you subtracting 100 minus the x? 100x minus x.
Because we have no recurring numbers. So our equation is it's like a normal equation where you can easily solve for it. Okay, let's see the difference. Let's do B. We let x be 3.375. Then we count. We have 3, so we multiply by 1,000. And then here we'll have 3.375. Then again, we divide by 1,000. Divide by 1,000. So get x is equal to 3.375 over 1,000. Then we go to C. We let x be 12.13 bar. Okay. We multiply first by 100 so that we can move the numbers under the bar one step to the left. So we have 100x is equal to 12.13 bar. If we divide it here by 100, we'll have x is equal to 1213.13 bar over 100. Still a fraction. It's a fraction now, but still a decimal on top. We still have the point there. In the other two cases, when we did that division, we had no points on top there. So it makes sense to just divide. But for this case, we have an issue. We still have decimals there. So we need to find a way to dodge the decimals. So what do we do? Then we'll say, okay, we won't divide. Instead, we'll solve these two equations. If we name the first one equation 1, the second one equation 2, then we can now say equation 2 minus equation 1, where we'll have 100x minus x equal to 1213.13 bar minus 12.13 bar. So all our equations must have same numbers after decimal when you are doing the subtraction. So 100 minus x will get 99. 100x minus x Then the other one, 13, those under the bar, they'll give us 0 there. And then 1, 2, 1, 3 minus 1, 2, we'll get 1, 2, 0, 1. Then we'll divide by 9, 9, divide by 9, 9. So get x to be 1, 2, 0, 1 over 9, 9. We go to E. We get x. I will go to D. We get x. B negative 3.532 bar. Now, the negative does not affect anything there. The procedure is still the same. So we'll count how many numbers. You always want to name your equation 1 as an equation which has all the numbers after the decimal under the bar. All the decimal numbers under the bar. So now we have 5 as a decimal, but not under the bar. So we have a job of moving 5 from the right of the point to the left, so that we can name that equation as equation 1. So we multiply by 10 because we only have 5 there. So we have 10x is equal to negative 35.32 bar. This will become our equation 1. Then now, another week, as you could see, when we tried avoiding the next step, it was hard for us to get rid of the decimals under the bar. So what we do is we multiply by 100 to now move the numbers under the bar one step to the left. So 10 times 100 will have 1000x. And then on the other side, we'll have negative 3532.32 bar. Then we call this equation 2. So now we have 1000x minus 10x. This is going to be 990x equal to the bars minus bars, we get 0 there. Then you have this subtraction to make. 3532 minus 35 here. We have minus, and then the minus for subtraction. So end up having a plus there. So you go on the subtraction. So here you have a 2, we have 1, this is 7. Here we have a 4, we have 1, this is 9. Then 4, then 3. So it will come here as negative 3497. Then divide by 990. Divide by 990. So you get x to be equal to negative 3497 over 990. Like that. So that's our key work there. So this is A, B, C, D. You will now allow me to give you a task on this question in a very friendly way. Kindly do E, F, G, and H. It's important that you practice. There's nothing new. All the concepts are relying on C and D. So as you practice there, you will know if you have understood or you have not understood. So if you have not understood, then you can inbox me. There I'll make you understand. So that we go to question 9. Question 9. A, show that 1 plus root 2 is irrational. Solution. If you don't want to stress much, if you have 1 plus root 2 there to show, and nothing has been said about root 2, then you can just say, okay, let root 2 be equal to A over B, where B is non-zero, A, B are integers, A, B do not have a common factor. You've just picked root 2. We'll come back to 1 plus root 2. So then we show that root 2 alone is irrational. So you say, this means that I'm dealing with root 2 is equal to A over B. Then you square. So we'll have 2 is equal to A squared over B squared. If we cross multiply, because we know 2 has a 1 down there, you will have 2B squared is equal to A squared. Wow. If A squared is the same as 2B squared, it means that if I have A squared and someone else has 2B squared, if that is money, then we have the same amount. It's like this person is having, if the kwacha is $1 equal to 18 kwacha, if I tell you I have $1, it's the same as I have 18 kwacha. If I tell you I have $2, it's the same as I have 36 kwacha. Because they are the same in terms of value. So now we have 2B squared equal to A squared. Because B is an integer, even if we square B, we'll still get an integer. If you divide, an integer is a number like 2, or like 4, like 3. So if we have B is equal to 3, then we square it. B squared will be 9. Then we multiply 2 by 9, we'll get 18. If we divide 18 by 2, we'll get 9, a whole number. Telling us that B squared is divisible, telling us that 2B squared is divisible by 2. But 2B squared is exactly the same as A squared. So we'll talk about A squared instead of B squared. So say A squared is divisible by 2. And so,
Sir,
hello.
why have you left out the 1?
No, I said we'll get back to the 1 after we have shown that root 2 alone is irrational.
Okay.
Yes. So A squared is divisible by 2. And this simply means that A itself is divisible by 2. Okay. When A is divisible by 2, then we can write A as 2 multiplied by some number R, where this number R is an integer. After we do that, we can go back to this equation here and say, then we have 2B squared equal to, we said A is 2R. So we can write A as 2R because a is squared, we'll square 2r. If we square 2r, then we'll have 2 squared is 4, r squared remains r squared. If we divide by 2, we divide by 2, then we'll have b squared is equal to 2 r squared. We are back to the argument of a squared. Now it's b squared. So say this implies that b squared is divisible by 2, which later implies that b is divisible by 2. Hence, the contradiction. And so, root 2 is irrational. Why a contradiction? We said that a and b do not have a common factor. But here we're talking about 2. We're talking about a being divisible by 2, a divisible by 2, b divisible by 2. If a number is divisible by some other number, it means that that number is a factor of that number. So having 2, a factor of a and a factor of b, contradicts the fact that we assumed that root 2 is a over b, which meant that root 2 was rational. But now, because of this contradiction, root 2 is irrational. Because root 2 is irrational, we can now get back. We'll now get back to the question and say, oh, the question was asking about 1 plus root 2. So now I'll say, let 1 plus root 2 be equal to a over b with a, b integers, b non-zero, a, b coprime. When you say coprime, you simply mean they have no common factor. Because they are coprime, and there are these assumptions there, so we get back and say, oh, let's solve for root 2 now. So we have root 2 is equal to a over b minus 1, implying that root 2 is equal to, common denominator is b, and then we'll have a minus b. Clearly, so you can even say, but a minus b over b is rational. And root 2 is irrational. Hence, the contradiction. And so 1 plus root 2 is irrational. So I've taken this way so that if the question reads as, given that root 2 is irrational, show that 1 plus root 2 is irrational. You guys know that. So you won't have to do this part because you have been taught that root 2 is irrational. The only thing you would do is this part here. But if nothing has been said about root 2, you cannot just come to the red line there. You have to do the first part, showing that root 2 is irrational. Then you get the combination, the sum, 1 plus root 2, and conclude after you get here. You say, since I'm sure that root 2 is irrational, because you have shown, then you can use the rationality of root 2 to disprove this equality here. And that's how you show this one. Okay, so we said we'll go up to question 10. So we'll log out and log back so that we finish our target. So we're on 9A. We quickly log out and get back so that we go to 9B, then 9C, then question 10.